Every morning, this facility begins the intricate process of transforming raw bone materials into vital industrial components. The factory relies on a constant supply. This truck alone carries thousands of cattle femurs, destined for processing. Guided by the dramatic beams of the forklift, the heavy crate of bones is carefully maneuvered across the factory floor.
Femur, the longest and strongest bone in the human body. Its surface reveals a complex structure designed for immense stress.
Using bright inspection lamps, workers quickly check each bone for quality before they move down the line.
Once the weight stabilizes, the bone is immediately transferred to the size-sorted pile, ready for the next stage of production. Every bone arriving at the factory is meticulously categorized before being moved into these vast, climate-controlled aisles. As the mixture reaches peak temperature, the undesirable fats rise to the surface, where they are mechanically skimmed away. Inside the high-pressure boiler, intense heat rapidly softens the bones, causing the residue to detach and dissolve into the churning bath.
This specialized hoist lifts those bones from the scalding boiler.
This is hydrogen peroxide at work. The intense agitation within the rotating drums creates a vigorous foam essential for industrial cleaning.
Submerged in a specialized hydrogen peroxide solution, the resulting oxygen bubbles aggressively whiten the surface of the bone.
Using incredibly high pressure, the machine ensures every last speck of debris is removed before the bone continues down the line.
The racks are loaded with thousands of bones, where powerful fans circulate warm air to ensure complete sterilization.
This rapid dehydration process, shown here in time-lapse, is essential. The bones contract,
These precisely cut bone blanks are now ready for the polishing stage, ensuring a uniform finish for medical application.
Using fine abrasive compounds and high-speed rotation, the surface is transformed from dull metal to a perfect mirror.
Here we see the finished product. Genuine bone buttons, hand-selected and polished before being set.
The beauty of the bone lies in the grain beneath the high polish, a texture highlighted by the craftsman's touch. From simple raw material comes a complex piece of engineering, the common bone button. From the rough, organic structure of the bone on the left to the smooth, finished precision of the button on the right.
This specialized diamond saw oscillates thousands of times per second, allowing it to cut through the femur with remarkable speed and accuracy.
The buttons enter the tumbler. As the machine spins, the friction begins to polish the surfaces, bringing out that factory shine.
Welcome inside the factory. This macro shot reveals the mesmerizing process of CNC engraving, where high-speed tools...
The high-speed buffing wheel is where the transformation begins, bringing the raw metal to a mirror finish. Each button is meticulously inspected before being placed into the velvet casing, ensuring perfection. From raw bone to polished finish, each button undergoes a rigorous process of shaping, drilling, and buffing before it meets our high standards. Here we see a femur being sorted. Each bone is inspected before moving to the rendering plant.
Using the macro lens, we can examine the trabecular bone in ultra-high definition. This density is crucial for the next stage of the grafting process.
Deep within these endless rows, the complex process of storage and retrieval begins.
Inside the drum, the bleaching process is underway. The dull bone rapidly transitions to this brilliant white as it passes through the specialized chemical bath.
This slow-motion cascade is crucial for achieving the pristine finish required for medical application.
This specialized laser system cuts through the metal, ensuring a perfect hole every time before the component moves to the next stage. Coolant floods the cutting surface as the high-speed spindle mills the custom profile, sending superheated chips flying.
Through a process known as mass finishing, these buttons are tumbled with abrasive media until a high-quality sheen is achieved.
A slow, circular buffing pass ensures an even application, transforming the raw material into a flawless, high-gloss surface.
The strength test applies calibrated pressure. As the gauge rises, the system conforms the pass, ensuring quality control.
Here we see the crucial stage, attaching the button to the finest wool cuff using a durable cross-stitch. What starts as a simple fastening operation quickly reveals the massive scale of this automated facility. The quiet transformation is complete. What began as raw metal is now a finished component, polished to micron precision.
The journey from a discarded raw bone to a finely polished button requires precision and craftsmanship.
Inside this massive industrial vat, the liquid undergoes a vigorous transformation, bubbling rhythmically at extreme temperatures. The cinematic footage captures the drying contraction time-lapse, revealing the bones hardening in high detail within the factory setting. This is the moment of truth. The cutting tool engages the metal, spinning at thousands of RPMs to create the perfect bevel. Utilizing advanced photonics, the machine drills through the blank with surgical precision, a process captured here in extreme slow motion.
The vibratory finisher works continuously, using specialized fluid to burnish the metal, rapidly increasing the luster mid-cycle.
The final hand polish is crucial, creating the rich, saturated, glass-like finish you see here.
The automated line ensures every component is placed with absolute precision, minimizing error and maximizing output.
From polished brass to intricate wood grain, this collection showcases the surprising artistry of the common button.
Every button undergoes rigorous inspection, ensuring only the highest quality components leave the factory floor.
A dramatic transformation from molten metal to mirror finish, handled with absolute precision in the clean room. Every component in this vast automated system is monitored here, yet the ultimate failsafe remains a simple mechanical override.
And here we have the central control interface, initiating the sequence with a single command.